Hello students. So we were doing exercise 5.1. Next question is question number 26. So find the value of k so that the function f is continuous at the indicated point. So f of x is given cos x upon pi minus 2x if x is not equal to pi by 2. Okay. And the value is 3 if x is equal to pi by 2. So at x equal to pi by 2, the value is 3. Okay. Now we have to find the limit. Limit as x tending to pi by 2. Okay. So we have to convert this limit so that the limit tends to 0. Okay. So if I take uh, x equal to pi by 2 plus h, okay, when x tends to pi by 2, h tends to 0. So we are changing this limit as h tends to 0. So in place of x, you have to put pi by 2 plus h. So limit as h tends to 0, a cos pi by 2 plus h upon, this is pi minus 2 pi upon 2 minus 2h. So this gets cancelled, pi minus pi is 0. So we'll get here minus 2h. And from this, that is pi by 2 plus h, means cos of pi by 2 plus h. So there is a transformation, right? Using the trigonometry, we have to find the value of cos pi by 2 plus h. Pi by 2 plus h means it falls in the third quadrant. Okay, and in the third quadrant cos is negative, so you have to take whatever the value, that is transformation is sine. Okay, so sine of h is negative, minus sine of. You are getting confused here, please go through the 11th standard trigonometry lesson. Okay, there I have explained about this, that is how signs change when you move through that quadrants. Okay. Minus a, limit as h tends to 0, minus k sine h upon minus 2h. Minus gets cancelled. Sine h upon h is 1 as h tends to 0. Okay, so the value is k by 2. Okay, now we have given that the function is continuous at pi by 2. So this is equal to, k by 2 is equal to f of pi by 2. F of pi by 2 value they have already given, that is 3. So k by 2 is equal to 3. So k is 6. Okay. Next question, find the values of k so that the function f is continuous at the integrated point. So f of x is given equal to kx square and 3. X is less than or equal to 2, x is greater than 2. Okay. So it is given continuous. Continuous means left hand side is left hand limit is equal to right hand limit is equal to f of 2. Okay. So starting with limit as LHL. Okay. Limit as x tends to 2 minus. So you have to take this function kx square. So this is 2k. In place of x you have to put 2. So it is 4k. Okay. RHL the value limit as x tends to 2 plus is your 3. Okay, and at 2 kx square. So LHL is equal to RHL. So we can write, as the function is continuous at 2, 4k is equal to 3. So k is equal to 3 by 4. Okay. 28. Find the values of k so that the function f is continuous at the indicated point. So f of x is kx plus 1. X is less than or equal to pi. Cos of x is greater than pi. Okay. So here it is given that function is continuous at x equal to pi. So what is the value at f of pi? This kx plus 1. So in place of x is pi, k pi plus 1. Okay. Then for left hand limit as x tends to pi minus kx plus 1. So pi k plus 1. And RHL is limit as x tends to pi plus cos of x. So cos pi, okay, 0, 1, 1. So this is minus 1, okay, cos of 180. So it is given continuous. Continuous means LHL is equal to RHL is equal to f of pi. Okay. So left hand limit is equal to right hand limit is equal to f of pi. So k pi plus 1 is equal to minus 1. So k pi is equal to minus 1 minus 1 minus 2. So k is minus 2 by pi, value of k. Okay. So next question, f is given continuous at x equal to 5. Okay, same way you have to do it. That is at 5, it is 5k plus 1. Okay. Left hand limit is x tends to 5 minus, it is kx plus 1. So you get 5k plus 1. Right hand limit as x tends to 5 plus 3x minus 5. So this is 5 3 is 15. 15 minus 5 is 10. Okay. 5k plus 1 and 10. So it is given continuous. Function is continuous. Continuous means LHL is equal to RH. So we can write 5k plus 1 is equal to 10. So k is 9 by 5. Okay. So next question number 30. It is given continuous. Okay, the function is given continuous. You have to find value of a and b. So here you have to take 2 and 10. Okay. So left hand limit of 2 is 5. Right hand limit of 2 is this. Again, left hand limit of 10 is this and right hand limit of 10 is this. So it is given continuous. So at both the points it is continuous. So I'll take at x equal to 2. Okay. LHL limit as x tends to 2 minus, it is 5. RHL limit as x tends to 2 plus, it is ax plus b. So this is 2a plus b. Okay. Now it is given continuous function. So LHL is equal to RHL, which implies that 2a plus b is equal to 5. Okay. This is one equation we are getting. Now for x equal to 10, LHL is limit as extending to 10 minus. So ax plus b, that is 10a plus b. For RHL, limit as extends to 10 plus, it is 21. So LHL is equal to RHL, as it is continuous, function is continuous. So 10a plus b is equal to 21. This is second equation. Now we have to solve these equations to get the value of a and b. 2a plus b, I am using elimination method. Okay, changing the sign. This 5 is 16. Okay, 8 to the a is 2. So 2 into, putting in first equation, 2 into 2 plus b equal to 5, 4. So b is 5 minus 4, 1. A is 2 and b is 1. Okay. Next question, you have to show that fx equal to cos x square is a continuous function. Now here the angle is x square. Okay. So we can take, we have, in the last video we have shown that cos of x is continuous, correct? That is, we had taken some point C, okay, and then yeah, like you have, if the x is tending to pi, then we take some point and write x equal to pi plus h, right? So as your x tends to pi, h tends to 0. So this we have shown. Okay, that is f of x equal to cos of x we have taken, and cos of x is our continuous. So you can refer that question. Now here they have given cos of x square, that is, this is one function, this is one function. So there is a function inside some other function. So this is actually a composite function, right? Composite functions are function is inside another function, that is like f composite g of x, that is f of g of x, we write like that it is. Okay, so two functions are there. Suppose your f is already taken, so take g. G of x is cos of x. Then another function h of x is your x square. Okay, so if I take this g composite h of x, okay, then this will be g of h of x. Now h of x is x square and g of x is cos of x. So cos of x square, which is our f of x. Okay. So we have proved that cos of x is continuous and x square is also continuous. It is a polynomial function. So both the functions are continuous. You can write the same steps as we have done for cos of x. So this is the function v1, f of x equal to mod of cos of x. Okay. This we have to prove that it is a continuous function. Now here also the same thing, that is, this is a composition, okay, of two functions. So there is one function that is cos of x and another function is mod. Okay. So we have g of x mod of x and h of x as cos of x. Okay, so if you take G composite h of x, this is G of h of x. H of x is cos of x and G of x is mod of x. So this is mod of x, which is our f of x. Okay, so we have to show that this is continuous and this is continuous. This we have already shown. Okay, you can refer it. So no, I'll not prove it again. You can write the same steps. Okay, this also we have shown that it is a continuous function in the examples section, I think. Yeah, before exercise we have done that. That is, you have to take left hand limit and right hand limit. Okay, at see how mod of x is defined is given as minus x and plus x. This is for x less than 0. This is for x greater than or equal to 0. So you have to take LHL as limit x tends to 0 minus. So here it will be minus x, which is 0. For RHL also you will get 0. At f of 0 also it is 0. So it is continuous at x equal to 0. Okay, and it is continuous at all the points. So we can say that this is also continuous, this is also continuous, the composition is also continuous. Next, they have taken sine of mod of x. Okay, so here also the same thing, that is sine of mod of x or mod. Yes, so this is sine mod of x. So here also two functions are there, sine of x and mod of x. Okay, so your g of x is sine of x and h of x is mod of x. So this is g composite h of x, g of h of x, g of h of x is mod of x. So g of this is sine, so sine of mod of x, which is our f of x. Okay, so you have to prove that this is continuous, this is continuous, so the composition is continuous. Okay, same steps you have to follow. Okay, so this is the next question. Okay, here also two functions are there. So this is, say, your g of x and this is your h of x. Okay, so you have to prove that g of x is continuous and h of x is continuous. So we have already proven that this mod of x is continuous, correct? Let's prove this h of x continuous. So according to the definition of mod, this is minus of x plus 1 for x less than minus 1, and this is x plus 1, that is positive value for x greater than or equal to minus. Okay, so now you take left hand limit as x tending to 1 minus 1 minus, so you have to take this 0. Okay, same you have to do it for right hand limit. Right hand limit x tending to minus 1 plus, so this is x plus 1 plus 1, so 0. Okay, at this is h, no? H of minus 1, this value you have to take. So minus 1 plus 1, it is 0. So here also it is continuous, that is at x equal to minus 1, the function is continuous. Okay, so both the functions are continuous, g of x and h of x. So our f of x, which is written as g of x minus h of x, okay, is continuous, as g of x and h of x is continuous.